Shall I start sharing my screen? This is just for entertainment purposes only, okay? But yes, we should start sharing our
You have the
screen.
floor, sir. Go ahead.
Okay, so I'm going to go ahead and do this. And I'm going to show you the first step of this process. So tell me, can you see my screen?
I
Yeah.
see your screen. Yes, we've
I
got a
see it.
spreadsheet.
You sure do. Okay, so there's a few things I'm going to draw your attention to here. So on the far left, in column A, you see the names of all the counties in New York, okay?
Okay.
And
Hey,
then you
they're
see
out of
their
order.
county IDs. Now, what I want you to see or notice is they're not in alphabetical order, and the county IDs are not in numerical order. You see that?
Yes, yes, I do. Yeah.
Okay, now here's what's important is that the county ID numbers are assigned in alphabetical order. Okay, so number one is Albany, which is the highest alpha
Albany.
name that we have out of the 62 counties in New York.
Yep.
Okay, so why are these scrambled? That's because this is what the algorithm does. Now, what we're looking at here are the partitions that are created by the algorithm that are used to disguise the fact that the algorithm is here, okay?
Nice.
So I'm just going to give you an image that I made to illustrate this. So on the left, this is kind of what we see when we don't know how to filter it and we don't know that there are algorithms there, okay? We have basically a dot pattern. It looks like a color blindness test. And what you need to do is you need to get rid of all the noise. And if you get rid of the noise, you see what you have over here on the right. You see what I'm saying?
Sure. A lot more organized.
Right.
Sure.
So I've just closed that. So it took me a couple weeks, along with a colleague who was helping me do this, to map this out. But what they've done is they've divided the what's called an SPO ID number. This is your ID number for the state. And they've created a bunch of partitions. And the names of them are, I'm calling them out of range, and then buffer zones where they don't assign ID numbers. And then they've got more out of range numbers up here. And then each of these counties are assigned to these ranges. Okay, so if you look at Schuyler County here, the range is this number 21,571,847 through this number. So every number in that range was assigned to Schuyler County. And then these ones highlighted in blue are the New York City counties. And the thing that makes this so tricky is that the out of range areas, these numbers are assigned to all the counties without any distinction, okay? So what's going to happen is I'll see in the Bronx, I'll see numbers that are assigned to the Bronx out here in the out of range territory. And the out of range is at the end and at the beginning. So that's basically all this number flack that's in the air that hides the presence of the organization within, okay? And I've seen this in multiple states, by the way, where they have a bunch of disorganized noise at the beginning of the number section and at the end, and in the middle, it's organized in a way that by an algorithm, okay? So when I first discovered this, I was like, okay, I have to map it out and I have to find out which county goes where and how they start out. And if you look at these, you see these are in order. So this is the order the algorithm puts them in, okay? And the algorithm scrambles the county ID order. Now, this is important because I didn't know that was going to happen. I was fully expecting that if this was some sort of normal, legitimate purpose, that the SBO ID order would match the county ID order. Does it make sense to you?
Sure. Like Albany would start at 0 and then it would go up from there, maybe.
Right.
Yeah.
And that's the other thing. The counties would actually start at 0 or 1. They wouldn't start at 8.5 million.
Right.
Okay. Which is what they did. And they wouldn't stop at 41 million, which they do, or 40.5, and then continue with all the counties mixed together. Okay. Which is also really weird. Okay. Now, the reason this is important is the first step of the filter is you have to know the range for your county. So for Seneca, it's this group of numbers right there. I'll just highlight them, okay?
Okay. Now,
Second thing,
I'm sorry. Is this for purposes of being able to recognize, or are you saying that if a nefarious actor wanted to determine what votes were available to cast for a particular candidate, they would have to know these ranges so that they could identify the numbers inside or outside?
they would need that, but that's only the very first step because this algorithm gets very complicated.
Okay, it's like a 20-step process, we'll say.
It's I don't think it's 20 steps, but it's a lot of steps.
Okay.
But this is what
He's talking about the New York algorithm, how it's defined by counties, and how the sequence in the cast vote record changes. Now, the cast vote record in Connecticut has been destroyed by Stephanie Thomas, so she needs to go to jail.
This is what allowed me to look for it. Okay.
Right.
So this stuff highlighted in green, you need those two numbers, and then you also need to know the county ID number. Okay. So you have to filter for those things. But then you also need a third thing that I discovered much later. I'm just going to introduce it now. Oh, actually, yeah, and I've got something I can show you to go along with it, and that is the date. It turns out there are 4 algorithms in the state, and they all appear to have been assigned at about the same time, which is somewhere in the range of June 1st to June 15th of the year 2007. Okay, so
right before Obama's election.
yeah, kind of curious, isn't it?
Yeah.
So, and think about it this way too, because I always find this kind of interesting. If you have the best method to do something, do you use the 3 inferior methods along with the best method, or do you just use the best method for everything?
Yeah,
right?
Yeah, that's what you would expect, sure.
Right. So these guys, you had 4 different methods, 4 different algorithms that they appear to have assigned all at the same time.
So he discovered...
Meaning each one has a different...
This guy discovered 2 other algorithms in addition to his old theory of having only 2. Now there's 4. So this explains how Lee Zeldon was treated in counties where he won with the same percentage of votes, and all the counties that he lost by the same percentage of votes. In other words, listen carefully.
Different purpose, okay? Which, by the way, is true. So we'll get into that in just a second. So let me close this. And here, I should make this a little bit bigger so you can see this. So what we're looking at right now is why the dates are important, okay? So let me, gee whiz, okay, I'm gonna just make this a little bit bigger, and this is really, really interesting.
Why the dates are important is because of Knowink, a software used in Connecticut to backdate votes. Okay, you heard me say it. You pay a fee and you can backdate any vote.
So what I've done here, actually, this is one of my colleagues did this, but I asked her to anyway. So this tells you or shows you all the registrations by the year of the registration date, okay? And it also, the colors have to do with whether they're out of range or in range. So in range is the organized algorithm territory, and the out of range is the disorganized stuff, right? So if you look at these, and I'm going to go all the way back to the beginning. So if you look at all these zillions of tabs, which I'm not going to go through because there's just way.
So they have an algorithms for out of range and in range. Do you understand?
Too many of them.
Sure.
But let's just go all the way back. There we go. Here's Albany. Okay. So here's your in range and here's your out of range. And what you should be able to see is that the out of range numbers start in 2007. Okay. And then you go to out, and by the way, they continue past that. But the reason is if you get your number assigned earlier and then you move, then you get a new registration date, which is later. So that's why the blues penetrate the orange. Okay. But the orange doesn't go below 2007. And then you see it's the same here. It's the same here. It's the same here. And it's like that for most counties, except for, interestingly enough, 4 counties that have a unique algorithm that they use.
Ooh.
This is one of them, Erie. Okay. So you notice they have out of range numbers that were assigned before 2007. Do you see that?
Yes. Back to 1957.
Yeah. So, and this is kind of interesting because what this appears to be is a whole bunch of backdated registration dates. Why would you backdate your registration dates? Okay, that sounds like falsification of the records, doesn't it?
Yeah, if they wanted to seed it long ago to make it look like it's somehow legitimate. But, or perhaps maybe it was a proof of concept. Maybe they...
Backdating registrations through the Department of Motor Vehicles? That's Chris Murphy.
Were determining how it was going to work out if they actually put it into use?
Well, there's a bunch of things associated with these backdated registration dates that are interesting. I'm just pointing out the fact that they exist right now.
Sure, okay.
And I'm going to go a little further. So And also, by the way, every one of these, Erie, Nassau, Westchester, all the ones that have large numbers of these use the same algorithm, which is called the metronome. By the way, when I say
The metronome used in Suffolk County. Amazing. 62,000 votes flipped in Nassau and 64,000 in Suffolk.
which is called, that's the brand name.
Yeah.
I made that name up because of what the pattern looks like to me.
Okay.
So
Okay.
so it's my branding, not the creator of the algorithm. I have no idea how they brand it. Okay. And then here's Westchester. So you can see these are all the same. And the funny thing about their county ID numbers is that each is double the value of the previous one. So it's 15, 30, and 60, which is also kind of interesting. So now let's go to a different county. So let's go to, I think it's Jefferson is the one I want to go to, and it looks like I forgot to open it. So I'm just going to go ahead and hit the open button right now.
Okay.
And I'm going to skip to a different one. Here, let's go to Genesee. Okay, so let's go to the way this looks when you open it up. Okay, so this is the raw data. Okay, so when I open it up, actually, let me look at a different one. This is not the way I want to look at it. There we go. Okay, so this is what it looks like raw. Now, the things that are important are these ID numbers. So you've got one set here. These are the state ID number.
Mm-hmm.
And then this set here is the county ID number. Okay, so everybody in the state gets one of each. Now, or supposedly, they actually wind up getting lots of them, I found out later, but that's a different story. In any event, what's important here is that the algorithm doesn't change these numbers. What it does is it creates a unique relationship between the numbers that's totally hidden, okay?
Okay.
And that relationship is the key to a third hidden ID number, okay? So when you look at this, you may not notice that there's anything funny going on, okay? So let me make it a little bit more clear. So here, what I've done is I've gone ahead and I've highlighted the county ID numbers after sorting these by state ID number. Now you look at these and they don't look like there's anything going on, right? They look like it's random. So let's take another step, and what I do is I decimalize it. So if you look at these numbers here, you see you go 1 and then it skips almost to 150,000. It goes down to 14,000. It's just going up and down all over the place, right?
Mm-hmm.
But what they've done is they have modified these numbers temporarily for the purpose of using the algorithm. So what they've done is they've decimalized them, okay? So they add a decimal point to the front of every number, which causes them to sort in a totally different way, okay? And then what happens is once you've got that decimal point in there, you see these are in perfect order, okay? So if you look at this 14,982, if you look at it as 0.14982 instead,
Yeah.
the next number is actually 0.4982,000, which is on the other side of this number. And here what you've got are these numbers that interrupt the sequence. So you've got the sequence that starts 1498, it continues, but then you got a 1055. And if you look back 10 rows, you got another one and another 10 rows, and you got another one.
Uh-huh.
And then you go forward and you got another one. And you notice these are really regular. Do you see that?
Every 10, yeah.
Yeah, and this, by the way, is totally invisible when you look at it here.
Mm-hmm.
You would never know this, okay? So, and I only know this because I filtered this properly, so it's the right SBOD range. And I've also set it up so they're only records that are in county, because if I allowed records from other counties, that would be people who'd moved from this county to another county, had the county code updated, but the ID number would be the same. And so they would create more noise. Okay, so I have to get rid of all that noise.
So this,
And then here we have
this is the
the start of
Attorney
the 100
General.
count. Okay, so this is row 85. So I go to row 196. And there we go. There's the next 100 count. And you notice this number sticks out also. It's not part of the pattern here. Do you see that?
I do, yes, yes.
Okay. So what we have here is we've got 3 patterns right now. We've got the ones pattern, where these numbers are separated by, the SPID numbers are separated by 1 digit.
Mm-hmm.
And then we've got the 10 counts. Okay. So, and these are separated by 11.
Mm-hmm.
And the reason they're separated by 11 is because it's 10 ones plus itself, right? So
Okay.
that makes 11. And then the 100s are separated by 111 because now you've added 100, right? So it's 10 ones, 10, and 100. So that's 111 different, okay? Now, one thing that's interesting about that is that those are what's called rep units. Do you know what a rep unit is?
No, I don't.
Okay, so let's show you what a rep unit is. A rep unit is any number where all of its digits are the number 1. Okay? And this is the core of the pattern that we're looking at, are these rep units. Okay? So in addition to the 100 counts, the 10 counts, and the 1 counts, you've also got 1,000 counts, 10,000 counts, and 100,000 counts, and in Kings County, 1 million counts, okay? But the 1 million count is just the easy way of saying 1,111,111. Because what they're doing is these numbers are going to be separated by those kinds of values. So let me go to where I broke those out.
This is very important, folks.
So right here, you see these are the rep units, okay? So it's 1 through 111,111. And then what they do is they also use 25%, 50%, and 75% of rep units for their start and end locations, okay? And I don't want to lose everybody in this audience as I start talking numbers. I just want to explain the basic mechanics of this, though. So it turns out you're going to see these numbers, which I call 1/4 rep units, and these 3/4 rep units all over the place. So for instance, in the 10,000s group for this particular county, which is Schoharie, you see the distance to the minimum SBOID number is 2778. And 2778 is exactly 1/4 of 11,111. And then just below it, the next number is 8333, which, when added to the 2778, gives you your rep unit of 11,111. Do you see that?
I do, yes.
Okay. So I hope you appreciate this is a complicated thing. Okay, so
I do. I think the audience does as well.
This is incredibly
All right.
important.
So then what I do, after I've done that, I have to calculate what numbers are supposed to be there because I know there are missing numbers. Okay?
Missing numbers.
And the reason I know there are missing numbers is because when I look at the top level view and I measure how many numbers should be there, right?
Mm-hmm.
And then I find out how many are actually there, I find out that there are discrepancies. So in this column O, I have listed how many numbers are missing. Okay.
Okay.
By the way, these pink ones, skip those because those are buffer
she's
zones that
online
have
with
no
me right
records
now.
anyway. Okay.
Okay.
But
This is a
these
New
are the
York
number of
Investigator.
ID numbers that were at one time assigned and were later
Hey, I'm
deleted.
watching a video.
Okay.
Okay. So the
Hey, I'm watching a video that's going through the 4 New York algorithms, and it's all about the ones. Every 10th voter is injected, and every 111th, and every 1,111.
What are they doing, John?
They're sequencing the county and state votes into other counties, into other top line and bottom line groups to change the numbers in a subsections so you can't catch them. But here's the proof right here. I mean, the sequencing of the falsification of the, in other words, if they follow the algorithm, they're going to have holes. They have to go back and fill them. This is how they did it. This is how Lee Zeldon had 77% of every county he won and, 45% of every county that he lost. There's 62 counties. So how do you have 62 counties with the exact same algorithm, except that he won less counties than he lost? You understand? No?
One less counties than he lost.
He won less counties at a larger margin than he lost. So in other words, they manipulated every county.
Yeah.
They decided which counties the Republicans controlled and which counties the Democrats controlled, and then they flipped the votes to fill in the gaps with the absentee ballots from the DMV.
Unbelievable.
Unbelievable.
DMV.
Huh?
From the DMV.
Yeah, well, that's the Department of Homeland Security. That's Chris Murphy. So New York got schooled by the U.S. Senate Subcommittee Chair of Department of Homeland Security. Huh?
Yeah, I understand.
The guy's
Well,
the
at least
number
you can
one
see
felon
it
in
now.
the country, huh?
At least you can see the 1-1-1 game.
Yep. Well, you were right. I'll call you later.
Oh, yeah, thank you.
That is the New York State human trafficking investigator, so you know. So the same people that are trafficking children falsified the election, which is what the New York State part of the Connecticut 5G lawsuit with Judge Meyer is all about. Anyway, I don't know how much you want to watch of this. I'll watch the rest, but let's wrap this one up here. I'm going to wrap this up right here.